Now we're doing question 17 on section 5.3, and they want us to integrate by using geometry. In other words, draw the picture of the associated function and find the area of that and equate it to this integral. So first of all, if we have x squared plus y squared equals 9, then y squared equals 9 minus x squared, and y equals plus or minus 9 minus x squared. And that's the equation for a circle of radius 3. If we eliminate the plus or minus and just go with the positive, then we have the equation for a semicircle of radius 3. So let's draw that. And here we are at 3, 0, 0, 3, negative 3, 0. And we're talking about just this area here. And we know the area of a circle equals pi r squared. Well, r is 3. So that's going to be 3 squared is 9. So 9 pi. But we're talking about the area of a semicircle, just half that area, and that's going to equal 9 pi over 2. So that's what our integral equals, and I'll segregate this, and this equals 9 pi over 2, and we're done. Well, now we're doing question 43, and we're going to use the rules on table 5.4. So we can break, according to those rules, we can break this up into two integrals and have a 2 and a t dt minus, now we'll have the integral from 0 to 2 of 3 dt, and that equals t squared from evaluating that from 0 to 2 minus 3t, and we're going to evaluate that from 0 to 2. And so replacing t with 2, we get 2 squared is 4, and minus 0 squared is simply 0, and now that minus, and replacing t with 2, we have 3 times 2 minus 3 times 0, but 3 times 0 is simply 0, so this equals 4 minus 6, which equals negative 2. Good. Okay, now we're doing question 49, and again we're using the table 5.4. And this equals, and we'll break this up into three integrals. The integral from 0 to 2, and I could factor that 3 and put it out here, but I'm not going to. I'm going to leave it right there, x squared dx, plus the integral from 0 to 2 of x dx, and minus, and I can factor that 5 out of there, and I might as well do that, the 0 from 0 to 2 dx. And now, reversing the power rule, we know we're going to add 1 to 2, and we get a 3. So that 3 is going to go in the exponent position, because when you take the derivative of x cubed, you get 3x squared. So we'll get x cubed. And from 0 to 2 plus, and now we're going to add 1 to that exponent. We get a 2, but there's no 2 here, so the coefficient there must have been 1/2. Now when we take the derivative, we get what we want, 0 to 2 minus 5 And the exponent on x here is 0. That's why we don't see it. X to the 0 power is 1, but now we'll add 1 to it, to that 0, and we get an exponent of 1. And we're going to evaluate from 0 to 2. Now look, this is rather cumbersome having all these separate evaluations. And we can put a parenthesis there, a bar there, and evaluate the whole thing from 0 to 2, and we'll be done. So let's see. 2 cubed is 8. 2 squared is 4 times 1/2 is 2. 1/2 of 4 is 2. 5 times 2 is 10, so that's negative 10. And then if we replace every x with a 0, we'll just be subtracting 0. So now we have 8 plus 2 is 10 minus 10, and I get 0 there, don't you? And we're done. Well, now we're doing question 59, and we have to find the average value. And that formula for average value can be found on page 320. What it is 1 over b minus a, in other words, the width of the interval, times the integral from a to b of f of x dx. Well, this is the area, and we're dividing the area by the base, and what we'll get back is the height, because base times height is the area for a rectangle. So when we divide the area by the base, we'll get the height of the rectangle that would have the same area as this curve will hit, as the area under this curve on the interval 0 to 3. So now, here we go. We'll divide by the difference of 0 and 3, which is 3, and then times the integral from 0 to 3. And look, t minus 1, when you square that, when you FOIL that out, you get t squared minus 2t plus 1 dt. Okay, so that's what we'll evaluate. So this equals 1/3 times, and the integral of the t squared is going to be 1/3 t cubed, I beg your pardon. Add 1 to this, and why don't we see a 3 out in front? Well, we must have had a 1/3 as a coefficient on t. Minus t squared. Added 1 to the exponent of 1, and why did we, if we take the derivative of this, will you agree we'll put a 2 in that position, plus t, and we're going to evaluate that from 0 to 3. So now we have 1/3 times t cubed. That's going to be 3 times 9 is t cubed, minus t squared, well that's 9, plus 3, and we've got it. Well, here the 3's divide out, and we get 1/3 times 9 minus 9 plus 3. Well, that's 0, and we just get 3 over 3, which equals 1, and that's the average value. In other words, that's the height of the rectangle, whose width is 3 units, that would have the same area as this area under this curve. And we're done.